Hello friends, good afternoon and welcome to EduSet Live Lectures. Dear friends, today in Computer Sciences we will be talking about wireless sensor network. To discuss this topic we have with us our subject expert Dr. Advitiya Sinha. Dr. Sinha is Assistant Professor in an eminent university in National Capital Region of Delhi. Without further ado, I would like to welcome ma'am to our studios and request her to start the lecture. Welcome ma'am.
Thank you. In this lecture, I will be discussing about wireless sensor network. Wireless sensor network is basically an emerging area in which a number of sensor nodes are used to deploy to perform data gathering tasks. This involves certain applications like health related applications, or it can be monitoring applications, battlefield applications, and various other recent trends involving underwater sensor networks, social networking with integration of course with sensor networks, etc. So just to start with, first we will give an overview of sensor network, that is the sensor node components, its types, the layout, the networking standards involved, network characteristics, several design challenges involved, and obviously since sensor networks are there, so data will be transmitted. For that, medium access design issues will be discussed, certain problems will be highlighted, performance enhancements for the same will be discussed, along with sensor network architecture and some associated security issues. Also, we'll go through some recent trends involving acoustic sensor networking, multimedia networking, integration with social network, and self-similar models for modeling the network traffic, and some energy harvesting methods, also popularly known as scavenging methods. Now the overview. Sensor networks are basically collection of large number of sensor nodes, and these sensor nodes are minuscule devices that are used for monitoring a huge field for like essential purpose, for example maximization of network lifetime, energy optimization, etc. Here the important components of sensor nodes are the sensing module, the computation module, communication module, and obviously these are the radio activities, so they have to draw power from somewhere. In case of sensor network, they are the battery based devices, so battery is the source of power, and unless otherwise mentioned, the sensor nodes might have an additional unit called actuation unit that imparts mobility to it. Also, we have a power conversion because we don't get the direct power supply, so we have to convert it. So we need a AD power converter. Now the main operations of sensor network is to gather data from the devices that are scattered around, and then whatever the data is gathered, they are processed or mined up, and then finally they are distributed among the nodes. Now these are the sleep states, because since our devices are very lightweight, economic, but still they are battery based ones, so they need the power to be optimized carefully, because with less amount of power we had to do a lot of tasks like transmission, reception, etc. So for that, it's very important to make the radio sleep for a certain amount of time period when it is not involved in certain radio activities. So these are some of the sleep states with different power levels involved. We can see that the processor and memory, it's a combination of when it has to be active, idle or sleep, and accordingly the amount of power being dissipated. Now, this is a sensor network layout. As you can see that in general there are a number of sensor nodes deployed over a given region. This region of interest is also known as the sensor field. And we have the communication link as the wireless medium. Through the wireless medium, the sensors are connected with each other, and these sensors are connected with each other with the sole purpose of forwarding data that they have been collecting, or relaying data from the other nodes, the nodes that are on the circumference, to the base station, which is also known as the sink or the central processing center. And the data, once reached to the sink, they can be used for mining up purposes, so that further interpretations can be drawn, and this can be again given to the external network. Now we have different sensor node types. Depending upon the purpose requirements, we have different sensor nodes available with us. Some are like noise level sensors that detect the level of the noise in a given surrounding. It can be temperature or pressure detection or humidity. It can also help in detection of the intensity of light or motion of a person. Even we can use sensors for predicting the quality of air, or whatever pollutants there are or not, etc. According to a different categorization, we also have nodes like Mica 2, Mica Z, Telos, and many more. Now these are the sensor nodes that are available in the market depending upon the needs, specific needs of the applications. Now we have wireless standards. These standards are important for transparently communicating, peer communication among sensor nodes, etc. So here we can see that different standards are introduced at different times according to application needs again. Now here, for example, GPRS, when GPRS is concerned, the application focus is made particularly on voice and data transmission. With Wi-Fi, which is a very well-known IEEE standard, 802.11, so there are different variations on that. So this is mainly used for any distance email or video transmissions. Bluetooth is for short distance communication. It's a good replacement of cables that removes the complication of wires, etc. And we have Zigbee, of course. It has a very good battery lifetime, but again, apart from its applicability towards monitoring and control applications, it cannot span over large areas, but it has a good lifetime. So again, whatever the needs of our application is, we have to model our standards according to that. Now these are popular IEEE standards that we were speaking about. 802.11 variation B, A and G. Now 802.11G is a very recent standard and is particularly taken into consideration as it supports good speed of 54 Mbps and is quite inexpensive, comparatively inexpensive than its other counterparts and other existing network standards. Now we have sensor network characteristics. Every network, every wireless network has some characteristics, and sensor network being a special kind of wireless network has its important properties. The first being sensor deployment density. This is all about how many what amount of nodes are being deployed over, say, a unit, a given per unit area. So depending upon the density also, we can have different interpretations of the network layout. Then we have data redundancy. Since there are a large number of sensor nodes dispersed over a given area, so these sensor nodes, they sense data over time and over space. And this spatial and temporal property of sensor network exploit correlation to a large extent. So we get redundant data from these sensor nodes. Now what we have to do with unreliability of sensor nodes. Now since we have a large number of sensors doing the same activity, but we should also know that these sensing devices are electronic, lightweight, sophisticated devices which can easily get worn out or get malfunctioned. So if the logic is, if certain number of nodes are not functioning properly, or their data has got corrupted, other nodes in that specific area over that specific time domain can compensate the missing sensed data, and therefore we can interpolate the results. Then we have limited processing power and storage, obviously, because these are battery devices. So battery power has to be optimally utilized so as to extend the lifetime of the network. Then obviously the wireless sensor networks are infrastructure less scenario. It's because there are no central coordination to these type of networks, as this type of networks are mainly found in areas where human intervention is not feasible. For example, if we want to monitor blast furnace, or we are just monitoring, say, some wildlife scenarios, etc., some dense vegetation, etc., for flood areas, if there is some victims in some flood areas, or any natural disaster victims are there. So in this type of areas, we don't have a good reachability of human beings. So there is a chance that no central coordination is available, and everything is like completely distributed. So we have to develop protocols and standards, everything in that manner only. Next, we have frequent topology change. Let me explain first what is a topology. Topology is a basic network layout. So what the point here is, in what manner the network is initially deployed, the network layout that is there initially, it might be different with respect to time. How it happens, as unless otherwise specified, the terrestrial sensor networks, in this case, the sensor nodes do not have the mobility perspective. But there are certain evidences, like in cases of wildlife monitoring, there can be situations where wind flows, or there is a flood and the sensor devices, they get displaced. Also, it can happen that in the same area where the wildlife is there, also our sensor nodes are there. So there's a chance that some animals can stampede over and the sensor nodes die out. Or it can even be a case like the sensor nodes, some particular nodes, they might be engaged in important tasks of relaying and transmission for constantly over a period of time. Then what happens, their energy gets drained out very rapidly. In that case also, the nodes may die out, and since the node dies out, its associated connectivities vanishes, and as the connectivity vanishes, their topology changes. So this can be a reason why the topology change. Also, we have sensor anonymity as one of the characteristics, yes, because in wireless sensor network, large, maybe hundreds or even thousands of sensor nodes deployed. So it's very difficult to nomenclature them or impart them some particular ID. So each sensor node is like anonymous. So it's difficult to find out which node is not functioning, or which node is providing malicious data, etc. So everything has to be done again in a distributed manner. So protocol standards, everything has to be compatible with this characteristic. Now the network design challenges. So since this is a network, we have certain design challenges associated with it. First being energy efficient communication. Being having a very less amount of energy reserve, it is important to develop certain strategies so as to elongate the lifetime and achieve better performance. Also, we have to take care of network coverage, because the concern, besides a network lifetime, the concern is also to properly ensure that our network is fully covering the area of our interest. So, this is important, as because we are gathering data which is environment specific. So if we are achieving a perfect coverage, so we can get a more accurate result. And obviously we have limited resources, We have to keep in mind that computation and communication is all what a sensor node involves. So we have to keep the latency also to the extent minimum. Next, we have high unreliability. Yes, the nodes are very unreliable because this type of nodes are generally deployed in areas where humans are not able to reach. Not only this is a factor, the other thing is, say we are surveilling some battlefield or wildlife or forest fire, anything. What we do is we take some amount of sensor nodes and we stochastically drop it from the airplane. So we are not actually reaching the ground also to deliberately plan whether what type of deployment strategy we have to follow. So it's highly prone to damage and malicious readings can be the results. So we have to be careful about that also. Apart from this, load balancing plays an important role as the density of the nodes is very high. So it's important, it's a very important challenge that we make optimum usage of these nodes. We should make certain balance, like some nodes should be engaged in a set of tasks and some other might be engaged in other set of tasks. In that way, what we can do is we are balancing the load or the task of transmission, the task of sensing, as well as the task of processing the sensed data. So there are several schemes available like cluster head rotation schemes, etc. Now, as we have discussed earlier also that wireless sensor networks are data-centric networks. It's all about data, sensing data from the outside world, gather it, mine it, and then send it. Send it in the sense it is transmitting. So whenever this word transmission comes, it means that we are transmitting our data with the help of certain wireless communication medium. Now, whenever the wireless medium comes in our mind, we know that it's a shareable medium of communication, because it's not like a particular cable that is dedicated, it's dedicating a communication line of service to 2 or 3 or more terminals. Here it's the wireless that we are talking about, so any transmitting station can contest to get hold of it and transmits its own data. So some design issues regarding how to acquire this wireless medium we have to be concerned about, so that minimum amount of collisions are faced. So what is the first point here is operation of access protocol should be distributed, obviously because our wireless network is distributed, so the medium access control should be, the protocol should be designed in a manner that it suits the distributed purpose of the sensor networks. The next is it should be able to support the quality of service network traffic. Most of the time we face a real-time burst of traffic. So it is important that we also enhance and maintain the quality of service that is required. It's not that we are only focused on the delay incurred. We should also be concerned about the accuracy of the data. Next, we have the available bandwidth. Obviously, the bandwidth is less with us, it's constrained, so we have to make efficient utilization of the same. Now, since our wireless medium is a shared device, so we have to make some strategy so that there is a fair allocation of this shared media among number of contesting wireless stations or wireless nodes that those want to communicate. So some fair allocation strategies are required. Now these strategies may be like the equiprobable ones, all are given same equal opportunities, or there can be some weighted strategies or priority weight strategies that can be applied. Next is control overhead must be reduced. Yes, it must be reduced because whenever the medium access is considered, we need certain control packets to be exchanged to check whether the channel is free for a particular station to acquire or not. For this, there are certain hand-checking mechanisms, etc. available. So during this hand-checking mechanisms, what we do is the sensor nodes, they first send a request packet, and if the request is sanctioned, they get acknowledged with the ACK or the ACK packet. So these are basically the control packets. So it should not be such that the control packets are more in order to have a transmission. So the control overhead has to be reduced, and it has to be scalable over large networks, because over time some of the nodes might get disturbed from their original locations, or it might get worn out, right? So number of other nodes can be introduced later over time. So it should have the capability, such networks should have the capability to support the scalability issue as well. Next, it possesses power control mechanisms in order to efficiently manage energy consumption of the nodes. There has to be different power levels. That is, if there is a transmission, a long distance transmission can be a short distance transmission as well. So according to the need, the power levels can be controlled. Next is time synchronization. Say if there are two nodes communicating, desire to communicate with each other, then their time or the system clocks has to be synchronized, so that whenever the transmitter is sending the data, it should also get received at the proper time. And overall, it should minimize the effect of hidden and exposed transmission problem. Now, what are these hidden and exposed terminal problem that creates hindrances during wireless transmission? Hidden exposed terminal problem is what? First, we will start with the hidden terminal problem. Here, it refers to the collision of packets at receiving node due to simultaneous transmission of other nodes. That is, in such a manner that the sending nodes are not aware of their common receiving end. For example, if we can see in this diagram that R1 is the common receiver and S1 and S2 are sending directly to R1. So what basically is happening over here is S1 and S2 are not they are not aware about each other transmitting to the same destination, but since R1 is the common neighbor to S1 and S2, it's getting simultaneous transmission. And in wireless there is a theory that whenever packets simultaneously, whenever it receives packets, they get collided and the data all in all they get corrupted. So this is known as the hidden terminal problem. Now here the collision occurs when both the nodes transmit packets at the same time without having the knowledge about the transmission of each other. Next is exposed terminal problem. Now what happens here is, let's see the diagram once again. Here say S3 is the victim of exposed terminal problem. Here, if say for example we are taking into consideration that S1 and R1 is presently communicating, and due to this ongoing transmission, S3 is not able to communicate with R2. Why? Because S3, S1 and R1, they are all in the same area, in the same zone. So S3 knows that there is an ongoing communication that S1 is being initiating with R1. So it will wait, and this waiting time is unnecessarily long, because it has nothing to do with the ongoing transmission. It has to send the data to a different destination, that is R2, but still it has to wait. So obviously we should have some performance enhancements. Major amount of energy is consumed in radio activities. So radio activities are transmission, reception, etc. So we have to control these activities. Also, since wireless channel is taken into consideration, so we know that it's vulnerable to transmission errors. So some kind of retransmission strategies has to be developed for the same. And such retransmission strategies should be made dynamically adaptable to low as well as high network load. So this is all about medium access, how we access the medium so as to have a smooth wireless transmission among the sensor nodes. Welcome back, friends. In this, we'll continue with sensor network architecture. Now, the design of sensor network architecture is very important as it has significant impact on the network scalability, the energy consumption, and the fault tolerancy of the network. Now, here we have different architectures with us. Now, on the basis of how the impact happens to the above mentioned factors, we have two architectures with us, the flat and the clustered architecture. In the flat architecture, as in the diagram it is shown, that all the sensor nodes are connected with each other and they are all connected to the sink. So, whenever the sink has some data or some message, some query, it sends it, rather it floods, it does not send peer to peer or to a particular station. What it does, it floods the message to all the sensor nodes. Now, the sensor nodes that possess the data matching with the query, it transmits it without aggregation, without data mining or without any processing. Now, this data that is being sent is again given to the sink or the base station through multiple channels. So, there is a huge amount of redundancy in transmission. So, the important drawback is rapid exhaustion of transmission energy due to bulk of packet communication. The other network that is with us is clustered architecture. Now, here instead of having all the nodes connected with each other and all the nodes are back connected with the sink, what we have, the sensor nodes that lie in close proximity with each other, they are grouped together and they form a cluster. Now, this is one way of clustering the nodes that are in close connection with each other. There are obviously several other strategies, other methods and mechanisms that are there with us for clustering the sensors. So, now once the field is clustered, what happens? Among the clusters, as we can see in the figure, that we have two clusters, And in each cluster, one of the member is designated with the task of cluster head. This cluster head acts as a pseudo central coordinator for that particular cluster, and its major role is to provide the intra-cluster data gathering from the member nodes, that when a particular set of nodes should be engaged over time for data gathering, etc. Also, it takes care of the aggregated data, whatever the nodes within the cluster, that is the member nodes, the nodes apart from cluster head, whatever data they sense, they communicate that data not directly to the sink, but it gives the data to the cluster head. Now, this cluster head then has the task of processing it, mining it up, and then reporting it to the sink. So, we can see here, instead of as in the first cluster, we have 5 nodes with us. So, instead of 5 different transmissions, now it is reduced to a single transmission that is being made by the cluster head to the sink. So, what we are basically doing here is we are reducing the number of transmission, we are increasing the amount of organization within the clustered network. Since a clustered network, so it is very easy to manage and debug. The reduction in sensor energy consumption can be brought about to a great extent, and also load balancing can be activated here. How, like say out of these 5 nodes in the first cluster, say a particular node is designated as a cluster head for some amount of time, or we can say that this is our epoch period. After the expiration of this epoch period, this task of coordination or the cluster head role will shift to other nodes, so that the bulk of activities that a cluster head is being performing so far will be shifted to some other node. So, this way what happens, the load is balanced evenly among all the nodes within a particular cluster. So, intra and inter-cluster activities becomes balanced, and this obviously provides a lot of scalability to the network. Now, we come to security issues. Now, these days security issues are very important, because we know that hacking and information disclosure are up to its heights. So, we also have to know what type of different security issues or types are there that we should be taking care of. First is denial of service attack. Denial of service attack is a type of attack in which the system is unnecessarily burdened up with extra traffic which has no meaning, but what the hackers do, they introduce large number of traffic to the bandwidth and the connectivity, so as to attack the performance of the networks. So, as you can see that there are 2 types, the bandwidth attack and the connectivity attack. Others are resource consumption. Obviously, if we are not having something from the outside to attack, it can be our own system constraints as well. There can be energy depletion. We have, say the nodes have lots of activities to perform, but these nodes activities are being constrained or restricted by the less amount of energy reserve with it. So, we have to innovate some ideas, some concepts, so as to recharge or replace these batteries of the sensors, so as to elongate the network lifetime. Other is buffer overflow. The data that is being gathered should be stored somewhere. The sensor buffers are small enough. They cannot be used for storing data that is a result of continuous monitoring. So, we can have some ideas like uploading the data over the cloud or something like that, so as to manage the stored data and reduce the effect of buffer overflow. Next is host impersonation. This is basically duplicating the identity of the authorized person and enter into the system, and once entered the person can malfunction with the data available. The next is information disclosure, very similar to host impersonation, but it is better known as hacking, as in this case what happens, every file, every service, every socket, port, everything gets vulnerable to the hackers, and they can regulate it from outside, that is remote access becomes available to them. And interference, this is a physical layer issue in which the transmission that is happening in bits and bytes, they might get interfered with each other, thereby corrupting the whole communication. Now this is the introductory part. Now let's start with the recent trends and applications that wireless sensors are these days into. The main focusing of wireless sensor networks are in various interdisciplinary concepts, like the first one is underwater sensor network. These are better known as acoustic networks. Now here the battery power is limited as usual as for the terrestrial networks. Terrestrials are the ones that are above the Earth's, on the Earth's surface, that is above the water surface. So for those type of sensors, what happens that we do have limitation of the battery, but here it is even more severe thing to consider about, because here we do not get the solar energy also. Even if we can extend our research over the terrestrial sensors, we can at least draw power from the solar. But here, once the nodes are deployed underwater, the solar energy cannot reach that efficiently underwater. So the battery becomes even more constrained. The other is bandwidth. Bandwidth is severely limited over here, and it has its own channel characteristics. The wireless channel underwater, it has own characteristics like long propagational delays, and these type of delays are generally varying in nature over time and over space. Also, we have high bit error rates during transmission. So all in all, we can say that these are the acoustic sensors. Obviously, we cannot use the normal sensors underwater. They are not built up in that manner. So we are using acoustic sensor networks that makes use of the sound energy to communicate. So these are more expensive. Being more expensive, they are sparsely deployed, and also we have a very less spatial and temporal correlation present among the sensors that are in close proximity. So the correlation is very low, and whenever we have to transmit some message to a relatively considerable farther distance, we have to use high amount of power. Next is wireless multimedia sensor network. Apart from acoustic usage, wireless sensor network can have some multimedia features as well. As you can see that networks of these are nothing but wirelessly connected devices, and these devices can be the webcam or microphones, etc., that can be used for retrieving content that have some multimedia stuffs in it. It can be audio, video streaming, or simple still images, or some scalar or vector data, etc. Now, the important applications involved for multimedia networking are the surveillance, multimedia surveillance. As you can see that these days we have there are private properties that has to be protected. Even public events also, some functions are going on. We can put a multimedia surveillance over them to record, to have a video streaming of every activities going on. Also, the national security, for this purpose also multimedia sensors can be used at the borders. Next is traffic congestion avoidance system. Here what happens, the sensors can be put on the traffic system so as to monitor the cities and highways. In this way we can find out, we can predict that what are the peak period of time where the congestion are likely to happen. Now once we know this, we can put some additional strategies to elevate them. Also, it helps for automated parking assistance. Whenever we are going to some mall or any parks or any public places, it's very difficult to find out the parking place for our vehicles. But if we have multimedia sensors with us, it can, before a certain distance, it can give us prior information that okay, we have some parking space over here in this location, and we can utilize this information for parking assistance. Next is advanced healthcare delivery. Here the patients can carry the sensors in form of some embedded devices like pendants or something, so as to monitor physical parameters like their body temperatures or heartbeat rates, etc. And this information, if it is like not normal, it's abnormal, it can be given to the hospitals or assistance that is available nearby, so that health services can be imparted. Another very important is industrial process control. Here what happens, several visual inspections that is not otherwise possible through human intervention, like blast furnace application, etc. It is very harmful for the humans to be around. The sensor networks with multimedia facilities can give us a visual inspection and also carry out certain automated actions on behalf of the humans. Now let's see what sensor network can do with the help of social networking. Now here we can see that we have lots of sensors with us. They are known as sociometric badges. It can be GPS, monitor sensors, microphone sensors, etc. Now these are the embedded sensors that already introduced before. They are engaged in capturing the location information, the movement information, how frequently a person is moving, etc. Background noise, foreground noise, some sort of behavioral data, etc. These data are those that are being captured by the sensor nodes, which are in form of sociometric badges, or it can be in form of say some rings, finger rings or belts, or wristbands that are in fashion nowadays, etc. Now these are individual specific data. So if we get data, this type of data from different individuals, we can gather a lot amount of social data, and obviously we can upload it on the cloud. And what we can do with this data we'll see, but let me first tell you what type of individual sensors are there that can be in form of sociometric badges. For example, we can see here lots of different sensors are there that gather social information about a person. It can be gathering blood sugar level, or oxygen level, body temperature level, or airflow sensors, etc. Now, once the data gets uploaded on the cloud, the data that we have sensed through our sensors and the information that we can get from the social media with respect to that particular individual. Say for example, what are his likings, what places he wants to visit more often, or it can be something like what movies he wants to watch frequently, what type of taste he has regarding books, etc. So this information together, they can be used for drawing some collaborative results. Obviously this type of information will be getting from not one individual, there can be different sets of individual around. So we can draw some conclusions like traffic control services, or modeling health behaviors, emergency management, so as to look at emergency situations of dangers, and for general awareness of the people. Also we can have this application for organizational analysis, etc. So collaboratively, this whole application is better known as social sensing. So this word is coming out from social, that is the social networking stuff, and sensing, that is the sensor network. So this is a very good, very promising domain. And let's see an instance of the organizational analysis over here. Say this is an instance in which we are taking the behavioral sensor data, that is the data that is being collected with the help of sociometric badges, along with the social media, the data from the social media with respect to a particular person, obviously. Also, since we are with the organization now, so organization, they generally maintain the performance data of their employee in form of surveys, self-reports, feedbacks, evaluations, some kind of appraisals, APIs, etc. Other electronic monitoring systems, that is there can be some multimedia sensors around to check out that how many effective number of hours that person is actually involved in working. Even there are electronic punching system these days. So there are a lot of ways in which the organization develop its own performance data. So altogether, if we mine this data with the help of sensor network, then what happens, we can generate some social and sensor based organizational design and engineering, so that we can get better groupings and better team members to be collaborating together. This is happening in this way, like if we are having 2 or 3 people together and we know that these people have same behavioral activities, they have same likings over the social network, or they are having same good records towards performance data, etc., then we can collaborate this 4 or 5 people within a particular team, so that the team performance can increase. This can happen in a teaching institute, it can be in a university level, or some big organizations, companies, R&Ds, etc. Because teams are everywhere, whether it is a research or a development area. So the main focus is our work, collaborate and communicate. Now we have self-similarity in sensor network traffic. Whenever a large amount of data gathering or large amount of data mining is involved, what happens? There is a very huge network traffic that is generated from one source to its destined location. So whenever such network traffic is initiated, there is a kind of self-similarity pattern that is there in the network traffic. Now this, with the help of wireless sensor networks application into self-similarity, we can generate and we can predict the time with the help of the time series data to find out what type of, what is the nature of the traffic, what is the pattern of the traffic, when this traffic gets congested or when it gets passed. With this knowledge, we can make some prior arrangement to handle the traffic situations, be it road traffic or it can be network traffic as well. Now we have energy scavenging methods. As we have earlier introduced that the sensor devices are battery based devices, so there has to be some way to regenerate their power, the battery power from which the sensor activities are boosted. So what is scavenging is basically, the energy scavenging is a way of powering an embedded system by harvesting energy from the environment. A sensor node is often called an embedded system because we have so many things into it, as discussed before, the transceivers, that is the transception, the reception, even the actuation. So a sensor node can be taken as an embedded system, and it can harvest energy from the nature. It can be solar energy, thermal, kinetic, mechanical, or it can be electromagnetic sources of energy. Now it can be drawn from different sources, like it can be the medical devices implanted, or it can be wireless weather stations, traffic alert systems, etc. So this is the scavenging methods that we can see, that we have energy sources with us. The solar cells, for example, if we are dealing with the solar system over here, that is drawing energy from the sun, we have energy buffer, and this energy is being used for controlling several activities, several sensing tasks and communication tasks. We have a predictor module also. This module helps us to provide us an analysis of the energy that is being drawn or regenerated from the solar devices, how long it will continue. Thank you very much. I hope this lecture will help you to enrich your avenues regarding wireless sensor network, its applications and recent trends.
On that note, I would like to thank Pam for this very enriching discussion, and thank you dear friends for watching our show. I hope you have come to understand what wireless sensor network is all about and what its various usages are. On that note, thank you dear friends for watching our show. Stay tuned and keep watching. Thank you.